Hello and welcome. This is John Broughton from Danfoss to this Q&A on cold room control panels. As I said, my name is John Broughton from Danfoss. I've been in the industry since I was 16 years old. Served my time as an apprentice, then worked in the industry, been also in the contracting business, and then worked in a wholesaler as a technical engineer, and now Danfoss for quite some years. So yeah, nice to see everybody. Just to let you know, we're live on 3 channels today. We're on Twitter, we're on YouTube, and we're on LinkedIn. So yeah, please give us some thumbs up. The idea is to have lots of chat and discussion on cold room control panels. So we'll try and not make it a presentation as such. I'd rather let's get lots of questions and answers, and also get some feedback on questions on control panels and so forth. So yeah, let's see where we go. I've got some material that we can sort of talk around before the questions come in. So yeah, let's see what happens. Also, be nice to know where everybody is listening in from. Any parts of the world. Normally we have people from all 4 corners of the world, Europe, the Americas, Middle East, Far East, everything. So it's always good to have a shout out. So thanks, Pars. Best company, Danfoss. That's nice to hear. Where are you, Pars, in the world? Okay. Yeah, just let us know where we're all listening in from. Yeah, so I've got some slides that we can sort of talk around. Behind me, you can see a cold room control panel that I've sort of rigged up with a few switches and solenoid valves and so forth that we can, talk about. So yeah, let's look at the few slides that I've sort of put together as discussion points. Now, yeah, cold room control panels. Very good question. Okay, so we've got guys coming in from Florida. Hi, Jamie. We've got guys from Canada on LinkedIn. Mohammed, Lebanon. Yeah, Ruan says, what controller are you using? It's a Danfoss AKRC113. Guys in from Sweden, Costa Rica, Kentucky, Kosovo, Denmark. Yeah, all over the shop. So yeah, that's good. India, Solomon. Hi. Turkey, Denmark. Yeah, lots of, so we're almost covering the 4 corners of the earth. I think Monterrey, Mexico. I bet it's a bit warmer in Monterrey than it is in the UK at the moment, that's for sure. Same as Pakistan. We've got Brazil. We've got Ian in London. Hi, Ian. I bet it's dark and cold down there as it is up here. Dominican Republic, that's nice. Montgomery, Alabama. South Africa, okay. That's a nice part of the world. I was born in Africa, by the way. That's just a little bit of private information. I was born in Kenya a long, long time ago. Italy, Slovakia, wow, all over the shop. Okay, so yeah, anybody got any questions, or shall we sort of go through the slides as we go? Yeah, let's put the slide deck back up and we'll sort of talk about it. So in the very beginning, and I'm going back to when I was 16 years old on the tools, a very, very simple way of controlling a refrigeration system, and I'm going to sort of focus about cold rooms because that is nice and simple. A LinkedIn user from the Netherlands, yeah, nice to see you. So in the very beginning, again, when I was sort of 16 years old, starting out in the trade, a very, very simple way of controlling the room temperature in a cold room. You didn't use a controller, you didn't use a solenoid valve, you literally just used a LP switch. And that LP switch controlled the pressure in the system, and that pressure equated to a temperature. So as the pressure reduced, you would cut out your LP, stop the compressor, and that was your basic control. So very, very simple. So Sunil asks, we've got a question up. What's the difference between EPR and CPR? Evaporator pressure regulator controls the pressure in the evaporator, and the crankcase pressure regulator controls the pressure in the crankcase. So to give you a couple of examples, if we've got a product in a cold room that we want to keep at a specific temperature, then we would control the evaporator pressure. If we have something like a blast freezer, blast chill, and we're putting in warm product, then we want to protect the compressor, so we'd use a crankcase pressure regulator. So those are the what's the difference. So another question from Sunil: what is the function of a liquid solenoid valve and how it regulates with the controller? We'll sort of come to that as we go through the slides. Basically, there is two options regarding a refrigeration system. You can either pump the refrigeration system down using a liquid line solenoid valve, or you can literally stop and start the system. I'll go down a couple of slides and we'll sort of talk around that, if that is okay, Sunil. So if we just put the slides back up again. So yeah, just sort of following on, I'll talk as we sort of go. Then we had obviously the cold room thermostat, again, very, very simple. No solenoid valve, no controller as such. Just a thermostat that literally stopped and started your compressor. So very, very sort of basic. Now, if we just go down another one, if we talk about that sort of simple type of control for a cold room panel, it's very simple. There's a famous phrase, keep it simple, stupid. You know, very simple things don't tend to break. The con of that is in an off cycle, we can get refrigerant migration. So that's not good. And then if we come to mechanical defrost, electric defrost, again, it's not good. And we can discuss sort of why that is bad as we go down. So if we talk about solenoid valves, and this is the question from Sunil, what is a solenoid valve? Basically, it is the, I would say, the preferred way to look after your refrigeration system. So when your room is down to temperature, your controller, whatever that is, and we can look at the various options of that in a minute, that controller would then, the thermostat would say, okay, my cold room is cold enough, and it would drop the feed to the solenoid valve. That would then start the system to pump down, and we would then pump the liquid down into the receiver of that condensing unit. System would go out on LP. The benefit of that is during the off cycle, we collect all the liquid refrigerant in the receiver. Now, that is a good thing, because if we didn't pump down and we just turned the system off, the liquid would migrate to the coldest place. Now, if the cold room is the coldest place, yes, that's okay, so it'll stay in the evaporator. Problem is when we start the machine again, all that liquid will then race back to the compressor and we can damage our machine. If the condensing unit is outside and it's in a colder place than the cold room or the application that we're dealing with, then that liquid will migrate to the compressor, and it will do that via the suction line. And it will sit in the crankcase of the machine, which we don't want. We don't want liquid in the oil. As soon as we start that machine, that liquid will flash up and it will dilute the oil and will damage the bearings. And in worst case scenario, we'll actually pump liquid and we'll kill our compressor. So that's you know, the main function of the liquid line solenoid valve. Okay, Rana asks, hi, have a nice live stream, thank you very much. Always nice to have some thumbs up if we're doing good. I don't like to get too many thumbs down. Will you include food tech? If you can expand on that question, Rana, then I'll see what we mean on that. If we're talking sort of supermarket refrigeration, yeah, we can talk about display cabinets and all that sort of thing. So just let me know a little bit more what you mean by that. That's fine. Okay, so let's just bob back to the slides a minute. And so that's the function of, let's say, the solenoid valve. And you can see there we've got our cold room, we've got our solenoid valve in the liquid line, and we've got our controller, whatever that may be. If we then sort of go down, and this is what we were discussing before, the pro of using pump down is we control refrigerant migration. It's good for defrost, because if we have an electric defrost, we're not heating up that coil that's full of liquid. So if we do that, we would use more energy, we would increase our suction pressure. Then when we come to start the machine, that suction pressure is going to come back to the compressor, and that motor of that compressor is going to struggle because the suction pressure is too high. And it looks after the compressor. Now you'll see on the slide there my little heart after the word compressor. The way I look at it is the compressor is the heart of the system, and we have to look after that heart. It's the pump of the system. If we damage the compressor, things don't work very well. So for me, everything we do in refrigeration, we have to look after the compressor, most important. Is there a con of having pump down? Personally, I don't think so. But yeah, let's. If anybody has some thoughts on that, let's hear it in the chat. That would be really good. So, and if we think about our cold room control panel, what is the main functionality that we want out of it, both as a refrigeration engineer, but also as an end user? And I've sort of listed some things on the slide there. We've got, cold room temperature display. We want to control the condensing unit. Do we do pump down? Do we do on off? We've got defrost management there, evaporator fan management, things like door alarm, man trap alarm, system alarms, temperature alarms, communication. So there's a lot of things that we can have, but what do we really need, and what does the end user really need? So I'd really like to hear in the chat if you think there are any more functionalities that you need from a cold room control panel. And somebody's just put up a little comment in there, no con to pump down, better to be safe. Totally agree. It's the way that I've worked, since I was 16, which was a long time ago now. But yeah, to me, it's better to be safe. We've got to look after that machine, and the last thing we want is to damage the compressor. Okay, so see where all the questions are coming in from at the moment. They look like they're all coming in from LinkedIn, maybe a little bit from Twitter. Okay, so Robert, what is the max diameter? What do you mean by that, Robert? What is the max diameter of? Are we talking suction line, liquid line? Yeah, just try and expand on that, and we'll see if we can do the. Yeah, please come back to that on the questions. David Lynch says, do the Optyma controllers have new parameters now, and what advantages are in it? Yes, there are. This one behind me is the AKRC113, which is a 3-phase unit now. Some of the new features that we've got in, we can now have a heating function as well as a cooling function in there. There is a defrost, let's say a smart defrost function, so that we can maybe skip a defrost, things like that. The communication side now on the Modbus, you don't have to put jumpers on the board anymore. That is already in there. So yeah, a few things like that. We'll try and go through that as we go. Still waiting for Robert with his question. Just seeing if it comes in. Okay, Sadiq asks, what is the main function of mechanical subcooler? A good question. If we think about our expansion valve, the expansion valve works with subcooled liquid, and if we have subcooled liquid, then we get the capacity out of the expansion valve. If the liquid is not subcooled, then we don't get the capacity out of the expansion valve. Now, the more subcooled the liquid is, the more capacity we get out of the expansion valve. So you have to be a little bit careful with subcooling. If you've got 15 degrees of subcooling, then you get a lot of extra capacity out of your expansion valve, and your expansion valve can be too large for the job. So you have to make sure that you size your expansion valve with the right amount of subcooling that you're actually going to get on the site. Also, subcooled liquid is very dense, so you do have to think about velocity in liquid line, long radius elbows, things like that, to avoid liquid hammer as well. So just think about that as well. Solomon asks, how do I select a hot gas bypass valve? Yeah, I mean, this is not sort of part of this discussion, but the best thing to do would be to use Danfoss Cool Selector, which is our selection software, and hopefully my colleague can put a link in the chat, so you can download Danfoss Cool Selector and you can do it on that. Hot gas bypass, just sort of generally, be careful of how much hot gas you want to bypass. I've always sort of relied on 2/3, a third and 2/3. Don't bypass too much, because then you will increase your suction superheat back at your machine, and then you risk killing your machine. So just be careful with hot gas bypass. If you want to bypass it, yes, you can put it back in the suction line, but be careful of your suction superheat. You would be far better to bypass hot gas into the expansion line, so at least you take some of that heat away. But just be careful on how much you actually bypass. So hopefully that answers those questions. Okay, so we wait for some more questions to come in. So we go back to the slides again. So yeah, just thinking about the functionalities that we've got there regarding a cold room controller. I've put sort of 3 pictures up on the side. We've got the typical Danfoss ERC little digital controller that looks after the evaporator. We've then, the second one down is the Danfoss AKRC cold room controller, like that one behind me, and then on the bottom is, you know, a cold room control panel that you could get made up at a control shop, for example, or as I used to do when I was much younger. You know, we used to make our own little control panels up for the jobs that we did, and we then, you know, designed the functionality within there. So there's various options, and you know, you can have a very, very simple control panel, or you can add as much functionality as you wish, really. So if we just go down to the next slide, and what I've sort of done here is talking about the Danfoss Optyma condensing units and how we interface is the wrong word, but sort of how they work with the evaporator. So on the left hand side here, we've got our evaporator, and then we've got a control panel, whether it's a Danfoss ERC or it's an AKRC control panel. And basically we bring in a voltage to the condensing unit, and we bring in voltage to the control panel. And the way that the system would work there is that that's on a pump down with the solenoid valve connected to the controller. So when the system calls for cooling, the solenoid valve is energized. From the condensing unit point of view, that is almost autonomous. It's on its own. The suction pressure would rise, LP would cut in, and the compressor would run. So that's how the system would work. When we are temperature satisfied, then the solenoid valve would close, unit would pump down. So the, let's say, indoor, the cold room part has its own power supply, and the outdoor condensing unit has its own power supply, and there is no link in between apart from the suction pressure. So that's example 1 of how you can wire up a system. We've just got a question in from, and I can't pronounce that name, so my apologies. I guess that's yeah, maybe Russian, but I'm not sure. In supermarket refrigeration liquid line, why do I see 2 solenoid valves in the same line, one small, one big? That's a good question. To be honest, I've never seen that. Is that with electric defrost, or is that with hot gas defrost? And are they in the same position, or are they in different parts of the line? Yeah, I'd be really keen to understand that. Yeah, that's an interesting one. So if you can expand on that, yeah, let's try and talk about it. Just say we've got somebody from Bolivia in. So yeah, hi Bolivia. Okay, let's go back to the PowerPoint a minute, which we've got. So that's example 1 of how we can wire up a system. Example 2, basically exactly the same, apart from we bring a fault signal in from the Danfoss Optyma condensing unit, and that feeds into our control panel to notify the end user that we have an issue. It could be a HP trip, it could be from the Klickson. It's a general fault signal to the control panel to say, there is something wrong here. I'm a great fan of that, because the last thing that the end user wants to know is, yeah, the temperature's risen, I've got a problem. Let's notify him before it gets to that point. So that's example 2, have a fault signal feeding into your control panel. Then we go to example 3, and again, there's no right way or wrong way to do this. It all depends on your choice, I guess. Here we have a single power supply come to the control panel, and then we've got the feed out to that to our evaporator for the fans, for the defrost heaters, feed out to the condensing unit, and then feed out to the solenoid valve. So again, we're working on a pump down. No benefit, I guess. What I would always say in any situation is, if you're working on the system, make sure that you lock off that isolator, so that you don't want somebody coming in and just turning on the power again. Now, something I've used for a long time, which is a long shackle padlock. Very, very useful. Lock off an isolator. It saves you getting a nice little tingle if somebody puts the power back on. So yeah, always remember that, please, ladies and gents. So we've got a question coming from David Lynch regarding cleaning down the microchannel condensers. Now, the microchannel condensers, basically the dirt, let's call it dirt, the fluff, basically sticks to the outside of the condenser like a mat. So the best way to clean a microchannel is with a stiff brush, and I'm talking, not a wire brush, please, just a stiff nylon brush, and clean the dirt off. That is the best way to clean a microchannel. If it is, grease, for example, if the condenser unit is outside a takeaway shop and there's a lot of grease in the air, then yeah, the only way, and this would stand whether it was a microchannel or whether it was a fin and tube, would be to use a proprietary cleaner, a coil cleaner from a wholesaler to get that dirt off. So that's the answer to that one, David. Hope that is okay. If not, please let us know on the chat, and we can take it a little bit further, please. Okay, so yeah, we'll wait for some more questions to come in. Let's go back to the slides a minute. Okay, so, and then we've got example 4. Now, let's just flick back to example 3. So example 3, or 1, 2, and 3, shows a Danfoss Optyma condensing unit. So we've got the compressor inside there, the condenser fan, the receiver, HPLP switch, and we've got the contactors or the relays, or depending on the size of it, to actually make everything function. So it is a standalone unit. Whereas if we go to example 4, which is a open frame type condensing unit, so we've got the compressor, we've got the condenser, we've got the condenser fan, we've got the receiver, HPLP, and basically all that is wired back to a terminal box. Now, obviously, to start that compressor, that has to go through some form of a relay, and that relay can be on the controller itself. If it's a bigger compressor, then it would have to be a contactor. It purely depends on the size of the equipment, what we actually need. Now, the panel behind me has got contactors in. This is actually a 3-phase panel, so this can cope with a bit more load. We'll come a little bit further down in the slides and we'll see the single phase version, which doesn't have contactors, it just has relays on the board. So depends on the application, depends on the duty, the size of the equipment, as to what you actually need in your control panel, and in real terms, how you're actually going to operate it. A question's just come in from Jonas. If my suction pressure isn't not PSIG when I hit set point, should I be concerned about the solenoid valve not fully closing? Well, it depends. I mean, it depends on the ambient condition. It depends on the refrigerant. In my time, again, many years ago, we always pumped down to balance point, and balance was always 0. If it does pump down eventually, then I wouldn't be too concerned. But obviously, if your solenoid valve is not closing and it's passing, then you will struggle to actually pump down. So yeah, you need to check your ambient condition and your pressure, and actually see what you've set your LP switch to. So that would be my answer to that one, at least. If your solenoid valve isn't closing, yeah, just make sure it's in the right way. Make sure that the diaphragm is actually in the right way if it is a diaphragm valve, and also make sure that there's no, dirt particles in that valve also. Another strange one, Jonas, is make sure you've got the right voltage coil on the valve. I know that's more opening than closing, but yeah, it is just worth mentioning that, if you've got 240, make sure it's a 240 volt coil, 110, etc., or 24 volt. Just make sure it's the right one. So hopefully that answers that one, Jonas. Yeah, let's bob back to the slides a minute, see if we get some more questions coming in. So that's example 4. We've got our open frame type condensing unit there. Everything's wired back to a junction box. So we need the relays and the contactors in the control panel to do the job, basically. So those are the sort of examples. And then what I thought of is, well, how do we actually control it? And again, I've got 2 Danfoss Optyma condensing units there. We've got the slim pack version, which is the cost-conscious version, if you like. Then we've got the Optyma Plus, which has the built-in electronic controller that looks after the condensing unit. I'll explain a little bit about that and the differences. Why do we have a controller in the condensing unit? Why do we have a cold room controller? Now, as we said when we sort of first started, is why do we pump down? Is pump down the best way to do it? Personally, yes, because we're looking after the compressor. Easiest and simple way on the Optyma control panel, this is a single phase version, whether it's single or 3-phase, is literally to control our solenoid valve from the compressor output. Yes, we've got all these other features. Obviously, we've got the defrost, we've got the fan output, we've got auxiliaries, we've got a volt-free contact here, which is an enable if we've got that within the condensing unit. Easiest way is to run the solenoid valve off the compressor output, because then we're working on a pump down scenario. And on the single phase version, straight out of terminal 14 and 15 on the board to the solenoid valve, works within a pump down scenario. We've just got a question coming from Ian. Can we talk about electric expansion valves and control panel options? Yes, we can, Ian, certainly. I guess the sort of question from my side is, are we talking from a supermarket display case point of view? Are we talking from a cold room evaporator point of view? Blast freeze? Do you want just superheat control, or do you want all the defrost functionality as well? So there's various options that we can provide with that, depending on your requirement for the system. And then you've got the choice of stepper valve, or you've got the choice of pulsing valve like the Danfoss AKV. And again, that depends on the application that we want to talk about. So yeah, if you were sort of elaborate on that in the chat, then we can discuss that. That would be fine. Abhijat comes in, how to check if the KP15 safety pressure switch is functioning or not during, and I guess do you mean pump down? Yeah, just expand on that a little bit, Abhijat, and we can take that a bit further. Okay, all right. Let's see if those can be expanded upon, and we'll go back to the slides. Okay, so yeah, that's the single phase version control panel, and that's basically what the single phase version looks like. So we've got the outer view, if you like, we've got the inner view, and we've got our control card with some relays on. and obviously we feed the mains in through a MCB, and the relays on there can control our refrigeration system. Okay, we've just got an answer back from Abhijat regarding preventative maintenance. How to check if the KP15 safety pressure switch is functioning or not during preventive maintenance. Sorry, that makes perfect sense. The simplest way that I would do it within the control system, if you want to, let's say, not break into the system, would be to disconnect the compressor, let's say mains, and then adjust the setting of the KP switch and see if it trips. That would be my sort of simplest way to do it. Yeah, I'd be interested if anybody's got any different thoughts on how you would do that, but that's at least the way I was sort of trained many years ago. Giannis has got a question. Could you tell us a little bit about the reaction of the refrigerant when we close the valve? I guess you're talking about the solenoid valve, Giannis. Yeah, I mean, we closed the solenoid valve on the liquid line, and yeah, the compressor then acts as a pump, and we basically pump out the liquid, you know, down the suction line through the machine, and then into the receiver. So yeah, I can't say any more than that. If you want me to elaborate on that, just sort of elaborate on the question a little bit, and we can touch on that. David Lynch has come up with a question. What is the recommended FST, for example, mutual room using -6, using 404? David, just expand what you mean by FST, and we'll answer that, because everybody uses different acronyms these days, and yeah, I'm not too sure what you mean by FST. So yeah, just come back on that one and we'll talk about that. That's fine. And okay, let's go back to the slides. There we go. So that's the single phase version. So there's the MCB inside and the board with the relay on. So fairly simple. Then we've got and these are the loads on the one phase panel. So you can see there, and we've got to remember AC1 or AC3. AC1 is heating element, so your defrost heaters. AC3 is you know, your motors basically. So yes, the relays are rated, as you can see in the panel there, 30 amps AC1. But if we're talking AC3, then it's a lot less. So you have to be aware of things like that. And in any control panel, you have to be wary of the, and it says it there, the sum of all the loads, because that control panel can only pull a certain amount of amps depending on the incoming supply, and obviously the breakers, MCBs and everything within the panel. So you've got to be a little bit wary of that. David's just come back with his question. Fan set temperature, no worries. We can talk a little bit about sort of defrost, and I've got my own, let's say, thoughts on where you, if you set your fan delay, drip down time, all those sort of things. If you mean your fan set temperature, David, when the fans click back in, or whether you mean your defrost termination temperature, yeah, just expand on that a little bit more, and we can cover that one. Sorry, it's just, yeah, to understand what we're actually talking about. Okay, right, back to the PowerPoints. So yeah, just think about the sum of your loads, and this goes for whether it's a Danfoss control panel or anybody's control panel. You know, things like you have to make sure that your compressor is not running when your defrost heaters are running, so that you don't exceed your maximum amperage, things like that. So if we talk about the three-phase version, again, the three-phase version has the same card in, basically, but if we just flick to that picture there, so, and that's exactly what's actually behind me also here. We've got the relay card here, but obviously because we're on a 3-phase version now, we've got contactors, motor protection, MCB, and you know, there's a lot more load in there, so it pulls a lot more load. Yes, we're spreading that load across 3-phase much better, so there's a lot more you know, components within a 3-phase panel than there is within a single phase. Let's just bob back up a little bit. Okay, so we talked about that. Now the 3-phase panel, basically, as we said, the same relay card that then feeds you know, the wires from the card into the control circuitry of the control panel. So instead of it being fed straight from the relays here, it's fed through the various contactors instead, just so that we can carry that extra load, basically. Okay, so David, just see if you can come back on that question regarding fan set temperature. If you're talking about the temperature when you want your fans to start back up again, I would always generally do that just below freezing, sort of -1, -2, so we don't blow any water across the product or onto the ceiling of the cold room. So yeah, hopefully that answers that question. If we're talking about defrost termination temperature, then yeah, that's another kettle of fish entirely. Very difficult to sort of set that. Yeah, and we've got some questions which are great, but yeah, please, if you've got any more, please come back to me. It's always nice to, when the fans come back on. All right, David, yeah, so yeah, the fan set temperature, I would always do it just below freezing so that we're not blowing moisture off the coil. Got to be a little bit careful, because what we don't want to do is have the compressor running and the fans not running for a long period of time, because then we risk getting liquid back to the machine. So you know, 0, -1, I'd be quite happy. What I'm sort of very interested in regarding sort of, you know, cold room controllers generally is if anybody's seen any other way of doing it. These are what I've seen over the past you know, years within refrigeration. Yeah, always interested to see the good, the bad, and the ugly, so to speak. So if anybody's seen any really interesting ways that people have wired up systems, please put it in the chat, and we can you know, we can take some discussion on that. But yeah, the more questions the better, because then you don't have to look at the pretty PowerPoint slides. We can actually have some good discussions. So yeah, let's see where we go. So we'll just go back to the PowerPoints a minute. So that is the 3-phase version. So as I said, all the functionality, whether it's the for example, the defrost heaters, you know, that has to go through a contactor. We've got the defrost heater contactor here, so we can pull a lot more load on there. And I've put the loads on the slide there that we can actually pull, whether we're on the 4 horsepower version or the 7.5. Obviously 7.5 is you know, a little bit higher load wise, so just to sort of think about that, be aware of that. And for example, if you've got a single phase unit or a 3-phase unit, would you choose a single phase control panel or a 3-phase control panel? It all depends on how you're actually controlling your refrigeration system. If you're only on pump down, then you don't need a 3-phase panel, because if your condensing unit, for example, has got the contactors, overloads, and everything within it, you don't need that functionality. You only need the simple functionality for your evaporator. The sort of changeover point really is your defrost load. If your defrost load is bigger than the single phase panel can cope with, then you'd have to go to a 3-phase panel. So just bear that in mind a little bit. Abhijat has come in with a question. Thank you, Abhijat. Is there any Danfoss cold room temperature controller which can record the alarm history, temperature history, and with digital input and digital output terminals? For this, we're using PLCs. Very good question. We have on the top of this controller up there, we've got a Prosa PRSC4, which is a little temperature monitoring device that I've rigged up on this site, and basically this has a GPS signal, so you can see the antenna there. It's linked into the Modbus on the controller via the cable here, and this will send alarms straight to your mobile phone. Also get email alerts, and that is aimed either at the sort of service tech, the service company, or the end user. And the best way to say is, if you want any further discussion on Prosa, please take that with your local Danfoss sales office. Regarding the other side of it, regarding alarm history and all that sort of information, yes, we've got controllers, we've got front-end systems that can do all that. Again, best thing to say, depending where you're based, Abijah, speak to your local Danfoss sales office and see what they can offer with that. Generally, for a temperature monitoring system, and it depends how detailed you want to get, then you've got to get the information from the controllers into that front-end system. The beauty of the Prosa device is that we can link into a comms network, or we can have basically a temperature feed into the Prosa. So there's various ways we can do it. I hope that's okay, but the best thing to say is please speak to your local Danfoss sales office and they will sort of help you from there. Now, David's come in with a question, David Lynch. Hi, David. On the single phase controller, what is the max amps the defrost heaters can draw before the controller dies? That's a good question. Let's just go back a little bit to this one. So this is the one phase controller. Now you can see defrost relay is 16 amps AC1, which is, as we said, resistance. Now, if you want to turn amps into wattage, there's a fairly simple way we do it, and we do WVI. So we know that we have, what did we say? We've got defrost, so we've got 16 amps. So we've got 16 there, and we've got 240 there. So if we do a simple calculation, and my maths is not very good, so let's do 240 times 16. So 3.8 kilowatt is our sort of maximum load, David, that we can that we can pull on that. So should be enough for a decent size evaporator. But yeah, just be aware of that, because although the relay is rated at 30 amps, as it says on there, that's rated at AC1. Resistive load is a little bit different, so it's 16 amps. And I always say 240 because in the UK, if you put your meter, we are pulling 240. I think the harmonized voltage now is 230, and it makes a little bit of a difference. But if you put a meter, we're pulling 240. So hopefully that was clear. I just got a question to sort of show that again. So I'll do it a little bit bigger. This is a very sort of simple. So we've got watts up here, we've got volts there, and we've got amps there. So if we know two of those, we can work out the other one basically in very, very sort of simple terms. So we said we've got 16 amps there, and in the UK hour, let's say 230, which is the harmonized European voltage. And then we basically, 230 times 16 gets us to our, what do we say, 3.4. Let's see if 230 does make a little bit of a difference. Shouldn't make too much. 230 times 16, so 3.6. So we can have 3,680 watts of defrost heaters, and you can't read my writing, so apologies for that, but basically 3.6 kilowatt of defrost heaters is the absolute maximum that we can pull on that relay. Okay, Jake asked the question, can the controller be monitored via BACnet? Not that I'm aware, Jake. I have to say I'm not a sort of, I hate to use the term expert, but not as far as I know at the moment. Best thing to say, and I say this a lot, is speak to your local Danfoss sales office and they will put you in touch with the correct person. Generally within our business, let's say, Modbus is fairly generic. BACnet is more a BMS system, as I understand. So not that I know of. So apologies for that. Yeah, let's see any more questions come in. Okay, no more questions at the moment. So yeah, let's just bob back to the slides again. So that is a single phase version with the loads. Sorry, that's the three-phase version with the loads. And again, we can do the same calculations. There they do it a little bit differently. They give us the wattage, and I don't know why we've given the wattage on one and the load on another one. It's a bit strange, but never mind. So yeah, again, integration of the control panel with the Optymas. Now, what I've done here is basically rigged up this is a three-phase version, so we've got a little bit more inside. And obviously I've not got a condensing unit down here, which is a shame, but we've got our control panel, and just to flip the lid up, obviously that's what we look at from what the customer sees. We've got a nice big temperature display. We've got the icons. We know that our fans are running at the moment, evaporator fans. We know we've got refrigeration up there, and this is operating via a pump down, because I've got my little solenoid valve up here working away, which is doing what it should be doing. And I would use the functionality on my phone, because we've got the magnetic tool on the Danfoss apps. Unfortunately, my iPhone doesn't have that functionality, so I've got the old-fashioned keyring that we did some years ago. Might still be able to get hold of it, and we can see at the moment that is going round, so we know our solenoid valve is energized. Now, a little bit of a talk around the panel. I'm just checking for questions. Obviously, we've got mains incoming, and this could be any control panel. It doesn't have to be a Danfoss control panel. This is a three-phase version, so we've got our mains incoming through our MCB. We've then got a motor protection circuit breaker, which is basically does the job of the overload that you could have on your contactor for your compressor. So we've got the compressor contactor, we've got the defrost contactor, and the loads for the evaporator fans and everything come off the board, because that's fine. The evaporator fans are not that big. Because this is three-phase, I've just wired it as single. We've got a transformer in there just to separate out the control voltage to 240 from 415, makes things a little bit safer. As I said, we've got the Prosa device up here, which is monitoring the temperature in my office, and we'll see that a little bit later on the slides, or I can show you on the phone. Just checking for questions, because we're getting a bit low on questions, everybody. So yeah, please let us have some more questions if you've got some, because that makes it more interesting rather than just looking at slides. So yeah, we've got our little control panel. We've got our solenoid valve, so this is working on a pump down. We've got our Prosa device up here in its own little box. It's taking its comms off the Modbus connection on the board here. So that's obviously feeding the information from the temperature sensors, which are nicely tucked in there, so keeping nice and warm. You can see at the moment in my office it's 23.7 degrees, so that's nice, even though it's a cold wintry day in the UK here. Okay, well, we've got some more questions. So Sergey asks, is defrost scheduled runtime or on-demand defrost also? There's a couple of ways you can do it in here. You can have a schedule, which is what I've programmed in at the moment. Every 4 hours it will go on a defrost. Defrost on demand is a very interesting word, and let's say within this, I wouldn't call it a defrost on demand. It is more like it will add time between the defrosts if the temperature of the evaporator is okay. That's the best way to explain it on this. If it was a true defrost on demand, then it would only defrost when it needs it, and it measures the air on, air off, liquid temperature, suction temperature on the evaporator with a little bit more functionality built in. So we've got to be careful of that sort of term defrost on demand, because it can be misconstrued a little bit. But within here, there is smart defrost functionality, but it's not as clever as a full defrost on demand system. Okay, Abhijat, another question. Thank you very much. For the Danfoss EV, can we put percentage opening superheat readings on PLC and HMI and monitor it? Well, this control panel does not operate an electronic expansion valve. This is for a cold room control panel, but it's not for electronic expansion valve. If you did have an electronic expansion valve, and it depends what we're talking about, whether we're talking a case controller, something like the AKC C55, or if we're talking just a pure superheat controller like EKE1C, then you can get information out of that on the comms, which you could log into a system and monitor, etc. Again, that famous phrase that I use a lot, sorry, please speak to your local Danfoss sales office and they can guide you on that. But yeah, there is ways and means of extracting that information out of a superheat controller to put it in a PLC, for example. So hope that answers that question, Abhijat. Okay, what else have we got? Okay, no more questions yet. See how everybody's doing. Okay, no more questions yet. I can't see any. Okay, so let's just bob back to the slides a little bit more. Okay, so we'll just wait for some more questions to come in. Questions are good. As I said, it keeps me from... and just to say hi, Michael, from Quebec. I bet it's quite cold in Quebec compared to here, maybe. I'll be interested to know. Yeah, always good to talk about temperature around the world. All right, let's wait for some more questions. Back to the PowerPoint. Sorry, we're flipping about a bit. So yeah, that is our little control panel that I've built. And when we talk about the functionality of things, basically what I've done on here is I've put a door switch in. Now it says D for door. And again, this is a Danfoss control panel. It could be anybody's control panel. If we click the door switch, basically we shut off the refrigeration, which I like, because then we are not, if the door is open, we're not putting all that moisture that's coming in through the door onto the evaporators. So we're not causing any, extra work for the refrigeration system, extra work for the defrost system, things like that. So a door switch is always a good idea. This has a safety built into it, so if the door switch is activated for a period of time, then the controller will override it and start the refrigeration system again. But I always quite like a door switch, because it stops a lot of problems. So we'll just put the refrigeration system back on again, and you can see there I've wired in my own little pump down LP, which again does the same thing. It pumps the system down. It's a bit of a hybrid panel, this. But yeah, that's a sort of functionality, I guess, of our control panel. Just come back to a question that's come in on the chat from Rana. Evaporator like falling film. Could you please explain the term? Rana, you just need to expand on that a little bit. If we're talking the rime ice on the evaporator, or the slime that we get on the evaporator, then yeah, just let me know a little bit and we can discuss that. Damien, for monitoring, can you use Danfoss Prosa IoT? Yes, you can. As I said, we've got a Prosa up there, which is connected to the Prosa cloud. So yeah, you can call it the Internet of Things. So basically, it goes up to the Prosa cloud. I'll just flick down a slide or two. We talked about loads. We'll come back to that one. Sorry to flip about a bit, but yeah, while we're talking sort of Prosa, this is basically the functionality of Prosa. So we've got our PRSC4, which is what I've got in the little box up there, and you can have a door sensor and a temperature sensor within the cabinet, and then that basically gives information into the cloud via a GPRS, which you can. This is that's the aerial for the GPRS, and then there's also Bluetooth connectivity local. So if I can find my phone on the desk here, I've disconnected my Bluetooth because if anybody rings me, then it cuts off this headset. But yeah, if I flick down to the next slide there, that is basically a screenshot of what you get on your phone. So you can see there we've got John's office. I live in Holmfirth, West Yorkshire, and the network status is good. This is not today, this was taken yesterday, so the internal temperature is 22.9, the door is closed, and we've got no active alarms. That's just to scroll down within the data. So you can actually get that via Bluetooth on your phone if you're close to the device, or you can get that via the GPRS if you're remote and away from the Bluetooth. So to me, incredibly useful. If I'm away on business, I can see what temperature it is in my office, and maybe I could wire it up to a few more things in here. Maybe the door to see if my door to the office is open, for example. But in real terms, if you have a cold room in a restaurant or cold rooms in a restaurant or a food factory, you can monitor them remotely. And if there is an issue with the temperature, you can set minimum temperature, maximum temperature, things like that, and you will get alarms if your system goes out of those situations, and also if the door's open, door's closed, all of that sort of thing. So to me, very, very useful. And again, please speak to your local Danfoss sales office, and they can give you much more information on the Danfoss Prosa. So yeah, hopefully that answers that question, Damien. And Mahadi asks, does it have Internet of Things? Well, it connects to the Prosa cloud. So yeah, again, the connection into the general IoT, that's quite a big word, is IoT, Internet of Things, obviously. Yes, this connects to the Prosa cloud. How you can take the data out of that, again, please speak to the local Danfoss sales office, and they can sort of help you a little bit further on that one. And Abijah asks an interesting question, actually, how to generate an alarm when defrost coil heater fails. Defrost is a very interesting subject, and I've done training sessions on defrost previously. Now, as far as I know, let's say from a refrigeration system point of view, there are various ways that you could generate an alarm if you have a defrost heater fail. And there is a lot of discussion on things like that at the moment, on monitoring the current or the power usage of a refrigeration system. So for example, you could have a CT on your defrost heater contactor, and if that is not pulling what you would expect amperage wise, then you can say, maybe one of my 3 defrost heaters, for example, is not working. So there are ways to do it. Nothing as an off-the-shelf solution as far as I know, but the easiest way would be to measure the amperage that you're pulling on your defrost via CTs, for example. Okay, Rana asks a question again. To expand, are concentration and cooling evaporators different? I'm not too sure what you mean by concentration evaporator. So Rana, if you could just expand on that from an application point of view, then yeah, we can. I can try and answer that one. That's a term I've not heard of before, so apologies for that. All right, let's just bob back to the slides a minute. I'll just go back through some. So, we talk about that one, we talk about that one, we talked about the loads. Loads is important, as I said, make sure things like you can't have your defrost heaters running when the compressor's running for obvious reasons. But yeah, just, it's common sense, but these things do happen. Okay, Patrick asks a question. What is the minimum temperature to keep it running smoothly? And that was auto-translated. So again, sorry, Patrick, I'm not too sure what you mean by what is the minimum temperature to keep it running smoothly. Are you talking about a cold room application, or the compressor, or superheat, or yeah, just expand on that a little bit and we can come back to it. Okay, what else have we got coming up in the questions? Okay, Rana asks regarding the concentration, food concentration. I think you might be talking about plate heat exchangers, Rana, regarding putting a food product, whether obviously a liquid through a plate heat exchanger, or maybe shell and tube, for example. So yeah, I mean, all evaporator types are different, whether it's an air cooler, water cooled, plate heat exchanger, tube in tube, pillow type evaporators on a milk tank, for example. So yeah, they are different, and the control of them is obviously different. Things like for a plate heat exchanger, for example, you've got to be very, very careful that you don't freeze your product within your plate heat exchanger, otherwise it will expand and it will damage your plate heat exchanger. Same as tube in tube, things like that. If you want to be very cold, then you would use something like a pillow type evaporator or a raceway coil within a tank. So there's different ways to do it, but yes, they are different. And the control of them, generally, obviously, you control with an expansion valve, but you have to be very careful of things like your refrigerant volume, your charge, the actual heat load that you are putting into the system. For example, if it was a milk tank, for example, don't run the refrigeration system until you have reached your minimum fill point within the tank, so that you actually have some load back to the machine. Otherwise, if there's no load, let's say a small amount of milk before the minimum fill point, then your machine will go on LP because there's no load for it there. So, there's lots of differences, basically. Tim asks a question. Do you think temperature control by air or product temperature is best? Tim, that is a $1 million question, I guess. If we talk about the supermarkets, for example, if we talk about a display case in a supermarket, some of them have a what we term in the UK at least a plastic chicken, and it is basically a block of like gel-like substance that reacts pretty similar to the product that you're trying to cool, and then you know that the product on the shelf has achieved its temperature rather than by cooling the air. So it depends who you speak to, and it depends on the application. From a supermarket point of view, yes, they love the plastic chicken. If you're in a cold room environment, again, good idea. Let's say general way that you would do it in a cold room would be return air temperature, because you've got so much product within a cold room and such a large area to cool. Then generally within a cold room, it's always done by return air, because that is a true reading of your cold room temperature and your product temperature. So that would be my sort of statement on that one. David asks the $1 million question, and it is a $1 million question, David, this. Recommended correct location of defrost probe, middle of coil or U-bends, etc. Now, I have got a slide possibly hiding down the bottom here from a presentation that I did some time ago. And just bear with us while I flick through all the slides. I don't really want to minimize and find it because then I have to faff around with settings. I think I've gone a bit too quick now. So there you go. That is the official location, if you talk to an evaporator manufacturer, of the best place for the defrost termination probe. So it's 2/3 up the coil and 1/3 in the coil block. Again, $1 million question, because you can always guarantee where you put your termination probe is not where the ice builds up. But that is the official answer from the evaporator manufacturers. Obviously, don't put it right on top of a heater because that's pointless. And what I've done in the past, as probably everybody, is you commission your system, you run it, you leave it for a week or two, and then you go back, and if the coil's clear, then fantastic. If the coil is not clear and you have a nice build-up, possibly due to airflow, possibly due to how they store the product within the cold store itself, then move that defrost termination probe to where your ice buildup is. But and I know that can be quite a challenge, because from 1 week to the next week, how they manage the goods in the cold store might be totally different. So hope that sort of answers that question, David. Patrick asks, are the operating parameters readable on GSM? The way that Prosa works, and again, I'm not an expert, I have to say, is that it's a machine-to-machine sim. So the data is pulled out of here on the Modbus into the Prosa. That goes into the Prosa cloud, and then that Prosa cloud sends that data back down in the form of alarms to your phone, email, etc. So I don't think they're readable at the moment on a GSM, because that goes into the Prosa cloud. But yeah, maybe in the future there is a way that can be done. But again, Patrick, sorry to say this a lot. Please speak to the local Danfoss sales office. And I know that they've put a comment on the chat regarding the page for Prosa, so please take a look at that. So I hope that sort of answers it a little bit. I just need a drink a second, hang on. Okay, so yeah, I'll just skip back out of my defrost presentation. I tried to put as much in as possible, because it's always difficult to see what questions you're actually going to get on the day, so to speak. Always got lots of slides. So let's go back up a little bit. So coming back to our slide deck a little bit, if we can just put the slides back up a second. So we talk about loads. One question that we get asked quite a lot is, we've got a cold room control panel and we've got a controller in the Danfoss Optyma Plus condensing units. What does that do in relation to what does the cold room control panel do? And in simple terms, that controller in the Optyma Plus condensing units looks after the condensing unit. Things like, and I won't read everything, but it gives us information. We can read the pressures and temperatures. It looks after the condenser fan speed, condenser pressure against ambient, operation of the crankcase heater against ambient, LP and HP control settings, looks after discharge gas protection, things like that. It's got a night setback function and a built-in comms that we can link into the Danfoss system. So that looks after the condensing unit is the best description. I've got a little bit more to sort of go through if anybody's got any more questions, but yeah, I need to ask for the sort of last round of questions coming up. I'm just thinking about the time for everybody. So if you've got any remaining questions, please post them on the chat. And I'll just go through the last few sort of slides, which is really the functionality things regarding cold room panels. And there's only 2 or 3, so it won't take too long. But think about thermostat management. We need the correct setting of the thermostat, and you know, I know customers like to play around with buttons, and you know, they might decide that they don't want their cold room at 0, they want it at -5. So you have to be aware of making sure that you can set the thermostat correctly, and possibly making sure that the customer can't alter it too much or at all. Things like night setback. Do we want to save energy? Yes, everybody wants to save energy. So, you know, maybe we can increase the temperature by 1 degree C on a night time when the door's closed. If we save, if we increase the temperature by 1 degree, we can save about 2% energy. And then also think about max minimum temperature alarms, things like that. Room management is a favorite of mine. Door operation, we said, you know, have a door switch on there to turn off the refrigeration when the door's open. Man trap alarm, if the door's closed, if it's a deep freeze particularly, very important. And light operation, don't leave the lights on basically when nobody's in there, things like that. We spoke about defrost a little bit, so we've got various options, and we spoke about electric heaters, off cycle, and smart defrost functions, things like that. Always things to think about, and that's defrost methods, which we've spoken about a little bit. We've spoken about Prosa, and we've done that. So that's the sort of end of the main slide deck that I prepared to sort of generate the questions. So yeah, just asking for any last questions. Hope that was good. If it is, please, you know, let's have a thumbs up. If it's not, yeah, let's have a thumbs down, but not too many. And if you've got any other sort of thoughts on content for live streams, then we're always, you know, really happy to get your feedback on what we can do, how we can do it, if this format works, if we can change it around a little bit. If you want more detailed sort of product training on something, then we can do that. Or if the chalk and talk, as I call it, is good, then we sort of keep doing that, really. We've got, I think we've got a couple of questions coming in, so we'll just wait for those to appear on the chat, hopefully. But yeah, it's, you know, that there is so much to discuss about refrigeration, and so many ways that it's done globally, because what fits you know, me in the UK, okay, I travel around quite a bit. I travel to basically 4 corners of the globe and see various things, and how we do it in the UK might be totally different to how we do it in Brazil, for example. So it's always good to get that input. We've got a question from Abhijat. Can we place the TXV thermal bulb just after a U-trap of evaporator on vertical suction line? Personally, I would always try and fit it before a U-trap, if you can, if you've got space. The reason I say that is because the idea of the U-trap, and I'll use my beautiful whiteboard behind me, just to make a little bit of a drone. I'll just move that over a little bit there. Hopefully you can all, let's go this side. That's better. If we've got our evaporator with our fan on, and we've got our U-trap like that, and let's say the suction goes up, we should fit our bulb there. If we fit it here, it's okay. Just a couple of pointers, really. Make sure that the capillary line comes out the top first. The reason we have this U-trap here is that if we do have any slugs of liquid and also oil, it will sit in the bottom of here, and then as the velocity increases, it gets carried over. Good and bad. The bulb will then sense that liquid, and it'll start and shut down. So it's better to have it here, because that's basically a constant flow. So I would prefer it there, but if you must have it on the vertical, please, so that's your bulb, please have the capillary coming out the top. The reason for that is if the capillary comes out the bottom, then we can lose charge. So yeah, take it out the top, please. Abhijit asks another question: why long pipe runs uses bigger diameter pipes? Again, sort of simple, and I try and look at things in a very simplistic sort of fashion, really. If we've got our compressor here with our, let's just draw a nice reciprocating machine, and we've got a the system's just gone on defrost. That obviously sucks on our suction, and we have to have a certain amount of capacity. Now, depending on that capacity of that machine, let's do kilowatts like that. If we've got a very small pipe, then the velocity in here is going to be, it's going to increase, because that's sucking away on our suction pipe. It's pulling the refrigerant back. The velocity is going to go up. If you want the velocity at the, let's say, the right level, then you need to increase your pipe size to accommodate that. So it's more about keeping the velocity correct in your pipes, because we don't want too high velocity in the suction line. Otherwise, we can have issues. We don't want too low velocity either, because then we don't get the oil back to the machine. Same with the liquid line. We want to keep the liquid velocity roughly below 1 meter a second, somewhere around there. If it's higher than that, we can get noise in the liquid line. Believe it or not, we can have whistling in the liquid line. And the other thing you can also get in the liquid line is you can get liquid hammer. So you have to keep your velocity right. So that's the sort of easiest way to explain it, Abhijit. And obviously, the more capacity we're doing, the more refrigerant that we're moving around the system. So the more refrigerant we move around the system, the bigger the pipe has to be to accommodate that capacity. But we've got to maintain the correct velocities in the pipe as well. We do have some infographic material on that regarding, be a pipe master or a pipe Jedi or whatever the phrase is that we use. And maybe my colleagues back in Denmark can put a link up to the infographic material that we've got. There's quite a lot of it in there, which is very good, and there's a lot on piping and things like that. A question's come in from Ketamane, if that's the right pronunciation, apologies. How to control humidity in summer? In a cold room, it's interesting regarding humidity, because people imagine, or let's say some people imagine, and I might have a slide somewhere on here. There we go. If we just put the slide deck back up a second, basically what this slide sort of shows is that the temperature and the humidity in a cold room is a function of the capacity match between our condensing unit and our evaporator, and the TD that we have on that evaporator. So if we want a fairly high humidity, we have a fairly low TD on the coil. So for every pass of air that we're taking across the coil, we're not removing that much heat. If we remove that much heat, we remove the moisture. So you can see there, if we have a very high TD across the coil, so the temperature difference between evaporating and air off, we are removing more moisture. So the main thing to say is that the easiest way to control your humidity is by the system match. There are other things you can do. If your humidity is too dry, there are third-party systems that actually give humidity into the room. Danfoss, as far as I know, we don't make that product, but there are ways to do it. There's also things like desiccant wheels, things like that. That's more AC, big rooftop type systems to remove the humidity out of the air. So there's various ways to do it, but the best start point is to get this capacity match correct between evaporator and condensing unit, or compressor and evaporators and get your TD right on your coil. That will save you a lot of pain if you've got really problem issues with humidity. If it's too much or too little, then there is third-party ways to do that. I do know cold rooms in, not so much in the UK, but in other parts of the world, where they have things where they overcompensate for the size of the evaporator. So if you want a very big TD on the coil, you have a very big evaporator to remove that moisture. So there are ways to do it. Michael says, could we practice defrost by gas and heater at the same time? Not really. There is little sort of point, to be honest. If we think of electrical heat, we're heating up the tubes, and how can I put this politely? It is a inefficient way to defrost a coil, but it's a very simple way to defrost a coil. Hot gas is better, it's more complicated. We have issues with hot gas and condensed liquid coming back to the machine. But when you use hot gas, you are heating up the coil from the inside, so we don't actually give that much heat to the ambient air inside the cauldron, for example. I've never seen a system that would have electric heat and hot gas at the same time, because then you would be increasing the temperature and the pressure even more of the hot gas inside the system. So I don't really see the point. But yeah, again, you know, I don't know everything for sure, as I'm told very often, particularly by yeah, let's not go there. But yeah, if anybody sees a system like that, I'd be really interested. So good question, Michael. Thank you. Okay. Any other questions coming up? If not, we will we'll draw things to a close. But I can see a few more questions, I think, coming in. Let's see. Just to let you know, we are almost 7:30 here in the UK. It's very cold. It's very dark outside. I can see my Christmas lights twinkling away in the background, which is nice. Okay, there we've got another question coming in. Liquid line coming out of condenser unit is 3/8. Can we connect 1/2-inch liquid line for piping? Yes, you can, but this comes down to that sort of question of you have to make sure that you've got the correct velocity in your pipes. It's a bit like, you know, take a solenoid valve, for example. If the connection is 3/8, is 3/8 the correct size, or is 3/8 just the size of your expansion valve? That might be right for the port size of the solenoid valve. That might be right for the duty of the solenoid valve, but your line size might be different. So always check your pipe size based on your velocity that you want in your suction and your liquid pipe. Don't take it as read that because we've got a 3/8 connection on the condensing unit that the liquid line can be 3/8. We are talking refrigeration, we're not talking AC. AC is a totally different set of rules, if you like. AC units are generally expanded at the condensing unit. In refrigeration, we expand at the evaporator. So always please check your velocity of your pipes and then decide your pipe size from there. We do have a piping tool in Danfoss Call Selector software where you can do pipe selection as well. And that will give you the preferred pipe size based on the conditions that you put in. So if you're in any doubt about that, please use Danfoss Call Selector. So yeah, that's I think we are sort of coming to the end of the questions. Thank you ever so much for taking the time to listen to me. Some very good questions. Hope the PowerPoints were not too distracting. It was just a way to sort of generate some questions. Yeah, appreciate the discussion. And yeah, for those of you who celebrate Christmas, then you know, that's in a few weeks' time. Have a good Christmas, and yeah, I don't think there's any more questions coming in. Abhijit says thank you. So thank you for the good questions, good discussion. Always good to talk refrigeration. Yeah, any more questions coming in? I can see quite a couple of questions coming in actually. Yeah, Michael says thank you, Merry Christmas. So yeah, thank you, Michael. If we want to take those other questions, we can take them quickly. I'm quite happy to. Okay, we've got a question. So let me move that over because it's blocking my view. How do suction liquid subcoolers affect efficiency of the system? That's a hell of a good question, and we've got lots of questions coming in now. In simple terms, and as I said, I try and look at things very sort of methodical, so to speak. If we think of a suction liquid heat exchanger, we are ensuring that we are subcooling the liquid, which is good. So we have subcooled liquid hitting the expansion valve, which gives us the correct capacity. We don't get excessive flash gas. But on the other hand, we're also warming up the suction gas. So it gives you a benefit. I can't tell you from a percentage point of view how much. For me, it's more about if we are unsure of the liquid quality, it's a good way to subcool the liquid. It's also a good way to ensure that the suction gas coming back to the machine is dry, so we've not got any liquid there. So yeah, it's sort of a bit of give and a bit of take is the best description, is the way that at least I would look at it. So yeah, hope that's okay. So everybody's saying thank you. Yeah, thank you for joining again. Always nice to talk refrigeration. It's the life that we lead. And questions just come in from Ryman. Typically, is electronic expansion valve type pull step application specific or relevant to capacity control type VSD digital? Yeah, that probably is a whole new topic of discussion. In sort of simple terms, if we have, I'll answer it fairly quickly on two ways really. If we've got one evaporator, one condensing unit, I wouldn't use a pulsing valve because a pulse valve opens and closes. If we're talking Danfoss AKV, if it's open 50%, it's open for 3 seconds and it's closed for 3 seconds. So your suction pressure does this a little bit, which is not good. If you then got a VSD drive on there that is controlled by suction pressure, then you have the possibility that your VSD drive will speed up and slow down as that suction pressure moves backwards and forwards. You can slow down the control of the VSD so that it smooths that out a little bit. But personally, if it's a one-to-one, I would always go stepper. If it's a supermarket installation, for example, or 3-4 display cases, no problem with a pulse whatsoever. So that's the sort of simple answer, if you like, but maybe that's a topic for another day. So yeah, thank you again ever so much. I think that's it. Everybody's saying thank you for joining, happy holidays, etc. So yeah, thank you very much, ladies and gents, and look forward to